problem number 5 is a 45, 45, 90 triangle. So here we're going to be using the 45, 45, 90 triangle theorem. We have the value of x, the variable x being used as one of the legs and y for the other. So as long as we don't use x or y to make our model, we should be fine. That means I'm going to use a. I'm going to say this equals a and this equals a, because over here on this side, I'm going to say this equals a root 2 to create my model. Now that I have my model, I'm going to start off with solving to find the length of that side. And I have very little space to do this in because I used so much for the previous problem. Okay, so now we have a root 2 equals 9. Divide by root 2 on both sides. And that will cause the variable a to be alone. And you will get 9 over root 2. You're going to follow a process very similar to what we did in problem 1 on a piece of scrap paper. It looks like I'm definitely going to need scrap paper here because I am kind of out of space. I'm going to simplify 9 over the square root of 2. I'm not allowed to have a square root in the denominator, so if I multiply by root 2 over root 2, then this value is equal to 1. Oops. And I get 9 root 2 in the numerator, because 9 times root 2 is just that. And then the denominator, root 2 times itself, just gives me a regular old 2. I love that. Unlike problem number 1, there is nothing we can do to simplify this, because 9 cannot be divided by 2. So this, ironically, is the simplified version of what we started with. So back over here, a is actually equal to 9 root 2 divided by 2. We still need to find the value of x and the value of y. So x equals a. Well, thankfully, we know what a is. So x is equal to 9 root 2 over 2. Not too bad. Thankfully, we did all the hard work already. Y is also equal to a. And so y is also equal to 9 root 2 over 2. And again, thankfully, we did all the hard work already. Since we have little space, we could put this scrap work here and just label it scrap if we wanted to. Let's see what's over on the back side. Number 6, another 45, 45, 90 right triangle. And the length of the hypotenuse here is 4 root 3. And we have an m and an n in the problem. That means we can use any variable other than m and n to represent our model to prevent variable confusion. I am going to use a. I usually try and stick with a unless there's an a in the problem. So those are my legs, so they're both equal to a. And this is my hypotenuse. It is equal to a root 2. Now in this case, the value that we were given was the hypotenuse, 4 root 3. So I'm going to have to solve that equation first. A root 2 is equal to 4 root 3. I don't see that root 2 hiding in there, so this might be a little complicated. We're going to have to divide by the square root of 2 in order to get the variable a by itself. A will equal 4 root 3 over root 2. Ooh, we have another situation where the square root of 2 is not allowed to be in the denominator. So we're going to have to simplify this problem to get that radical to go away in the denominator. We're going to multiply by a value equal to 1 that gets rid of the denominator. Root 2 times itself is just a plain old 2. That's why we're choosing this value of 1. Root 2 divided by root 2 is equal to 1. Now we multiply straight across here because this is a fraction times a fraction. 4 root 3 times root 2 is 4 root 3 times 2. Well, that can be simplified. 3 times 2 is 6. So 4 root 6 over 2. Ooh, unfortunately, that can be simplified too. 4 divided by 2 is 2. So we have 2 root 6. We know root 6 can't be simplified because the factors are 3 and 2. Those are both prime numbers, so there's nothing else we can do with this. This is the simplified version of the fraction we started off with. So the value of a in our problem is going to be equal to 2 root 6. That, unfortunately, is not the answer, though. We need to find the lengths of these two legs. M is equal to A, and N is equal to A. We just found the length of A. We now know what the value in the model is. So the length of one of the legs is going to be 2 root 6, just substituting that in. And the other leg will also have the value of 2 root 6. Oops. Didn't mean to put that there. Okay. Hopefully that is clear. And we have now shown all 3 performance indicators for that problem. On to the next one. 4 root 2 is the length of my hypotenuse. I have a 45-degree angle, so this is also 45 degrees. I have x and y given, so I need to use a variable other than x and y to avoid variable confusion. I mean, I could use one of those, but we're getting into a gray area where it can be difficult on other problems. For example, right now I could use x because x is actually the length of that side. And then I could say y equals x. And I could see this equals x root 2. On this problem, it makes sense. On a lot of the other problems, like if we look at question number 8, I have an x. But if I try and say that x is equal to x here, that's not true. And I can't say this equals x because I have an x already here. And so rather than having the potential for variable confusion, I am just recommending that you use a different variable than one that is in the problem to make it clear. Some students will be able to successfully use the variables that are given to avoid variable confusion. I'm just going to use a here to keep it simple for myself. This is a, and this is a root 2 using the model. And this is the 45, 45, 90 triangle theorem. And to solve this problem, I already have this side kind of isolated. 4 root 2 equals a root 2. I just need to get the variable a by itself. Divide by root 2. These cancel. And we get 4 equals a. Wow, that was easy. Now that we know that the length of the value of a is 4, that means we know the length of the other two sides. A equals y and a equals x. That means 4 is also equal to y and 4 is equal to x. And we're done.